Right now, sitting still, you're moving. Faster than a jet, right now. Earth spins you at incredible speed. 1670 kilometers an hour, unnoticed. You feel nothing. Zero wind, zero shake. Now imagine it just stops. You've probably seen videos about this. Here's the problem, they're not quite right. Quick favor, like, subscribe, and comment. It really helps this channel grow. So why don't you feel it? You're moving with the Earth, together. Like a plane cruising smooth and steady. No sudden lurch, just steady motion. But speed changes depending on where you stand. The equator spins fastest of all. The poles barely turn at all. Distance from the axis makes the difference. Picture the whole planet as a record. Everything turns together, once every day. One full spin takes 24 hours. That spin never stops, never has. Until now, in our thought experiment. Let's really imagine it slamming still. What actually happens next? Buckle up. This is where most videos get it wrong. Let's actually watch it happen, slowly. The ground stops, in an instant. But the air above doesn't get the memo. Neither do the oceans, or you. Everything not bolted down keeps moving. At 1,670 kilometers an hour, sideways. Air moving that fast becomes a weapon. Thousands of times stronger than any hurricane. Roofs peel back like paper lids. Trees bend flat, then snap away. Loose cars start to tumble and spin. Dust and debris fill the sky. The family watches from a sturdy shelter. Safe inside, but the world outside roars. Meanwhile, the oceans surge like tsunamis. Water piles up, racing toward the coasts. Coastal towns brace behind sturdy sea walls. A newsreader tracks the chaos, live. Screens flash red across the globe. Every ocean, every coastline, affected at once. It sounds like the end of everything. This is the moment most videos stop. But here's what they leave out. Bridges sway, power lines snap loose. Cities plunge into sudden emergency darkness. Emergency crews scramble to secure shelters. Animals sense the chaos and hide. News anchors struggle to keep composure. The whole planet seems to hold its breath. Minutes feel like hours, chaos everywhere. Then, slowly, the fiercest winds ease. This isn't just one city's problem. Every longitude gets hit, one after another. As Earth's old momentum sweeps around the globe. Tokyo, then Delhi, then Cairo, then Rio. The wind wave circles the planet once. A single, colossal, planet-wide event. And then, just as fast, it fades. Here's the problem with that whole scenario. An instant stop needs something to stop it. A break, a force, a wall in space. Nothing like that exists out there. Physically, Earth cannot halt in a snap. So that dramatic version? Not realistic. What is realistic is far stranger. A slow, gradual slowdown over time. And a slowdown is already happening, actually. The moon's gravity gently tugs at Earth. This is called tidal friction, a real force. It slows our spin by tiny amounts. About 2 milliseconds every single century. Barely noticeable, but real and ongoing. We covered this slow drag in our moon video. So this isn't pure fantasy, just extreme. Now imagine that process wildly sped up. Scientists actually measure this, precisely, today. Atomic clocks track Earth's spin constantly. Sometimes we even add a leap second, just to keep our clocks in sync. So yes, real scientists watch this daily. Which makes our thought experiment grounded, somewhat. Now, let's push that slowdown further. So let's fast forward that slow drag. Not in a snap, but over years. Each day grows a little longer. First you barely notice the difference. Then clocks and calendars start slipping. Days stretch past the normal 24 hours. Remember that, the real changes start now. First, a day stretches to 30 hours. Sunrise and sunset both creep later. Then 60 hours. Then even longer. Eventually, a full day equals half a year. One sunrise, one sunset, 6 months apart. One side of Earth faces the sun always. That side bakes under endless daylight. Temperatures there could soar past boiling. The other side sits in endless night. Deep cold, far below freezing, forever dark. It's a bit like the moon and Earth. The moon already shows Earth one face. Always the same side, forever facing us. A slowed Earth could end up similar. Locked, with the sun instead of us. Two permanent worlds, on a single planet. One scorched, one frozen, a line between. Along that line, a thin livable strip. Perpetual twilight, the only comfortable place left. Weather itself would transform completely too. Constant temperature difference fuels nonstop wind. A permanent storm belt forms at twilight. Plants and animals would need to adapt. Some might migrate along the twilight line. Others could vanish, unable to adjust fast. Earth's ecosystems reshuffle, dramatically, over centuries. Nothing about daily life stays the same. But the day length isn't the only change. Remember Isaac Newton, back in 1687? He studied Earth's shape, closely, mathematically. He realized Earth isn't a perfect sphere. Spinning makes it bulge slightly at the equator. About 21 kilometers wider at the equator. Like a spinning ball of pizza dough. Centrifugal force pushes mass outward, gently. That bulge exists because Earth keeps spinning. So what happens when the spin fades? Today, satellites measure that bulge precisely. GPS systems rely on knowing Earth's exact shape. Without accounting for it, maps would drift. So this bulge isn't just old theory. It's part of the technology you use daily. Every mapped road depends on this shape. Now imagine that shape starting to change. Without spin, that bulge slowly retreats. Mass and water shift toward the poles. The equator narrows, the poles swell outward. Earth edges back toward a rounder shape. That shift drags enormous amounts of water. Sea levels rise dramatically near the poles and drop noticeably near the old equator. The whole map of Earth begins shifting. Coastlines redraw themselves, worldwide, dramatically. Some cities end up underwater entirely. Others find themselves miles from any coast. Maps you know today become unrecognizable. That's the twist most videos never mention. Not wind. A changing planet, reshaping itself. And that's still not the whole story. There's one more invisible change, overhead. Remember that. A shield above depends on this too. That shield is Earth's magnetic field. Invisible, but constantly protecting you, always. It deflects dangerous radiation from the sun. Without it, life would struggle to survive. So where does this shield come from? It comes from deep inside the Earth. From something scientists call the dynamo effect. Meet Walter Elsasser, a 20th century physicist. In the 1940s, he explained this dynamo. Deep down, liquid iron churns and swirls. That churning iron, plus Earth's spin, generates electricity. Think of it like a natural generator. Spinning metal creates a magnetic field, naturally. That field becomes Earth's protective shield. Remove the spin, and the dynamo weakens. Less spin, less churn, a fading shield. With a weaker field, more radiation gets through. Skies fill with color, unexpectedly, everywhere. Auroras, normally seen only near the poles, now shimmer above the equator too. People everywhere look up and wonder. It's beautiful, but it's also a warning sign. More cosmic radiation reaches the ground below. Over a very long time, that's a real risk. In the most extreme, long-term case, the atmosphere itself could slowly erode. That's what likely happened to Mars, actually. Mars lost most of its magnetic field long ago. Its atmosphere thinned out over billions of years. Earth, without its shield, could follow slowly. But that's a very distant, gradual worry. For now, just enjoy the light show. It's not just pretty lights at stake. Satellites could fail under stronger radiation. GPS, phones, power grids might glitch badly. Astronauts would face serious extra danger. Modern life leans hard on that shield. A weaker field touches almost everything we use. So the shield matters more than you think. Which brings us back to that light show. Here's one last surprising little detail. Right now, spinning creates a tiny outward push. It's called centrifugal force, working against gravity. At the equator, it makes you slightly lighter. Without spin, that push disappears completely. You'd weigh a little more at the equator. Just a tiny fraction, barely noticeable really. So could people actually survive all this? Probably, but life would look very different. Farms would move deep underground, sheltered fully. Solar panels stretch across the twilight strip. Wind turbines spin non-stop along the boundary. Cities cluster tightly along that thin strip. Insulated domes protect against extreme temperature swings. Trade convoys travel the ring, day and night. Not doomsday, just a very different lifestyle. Humans are remarkably good at adapting, actually. Give us centuries, and we'd figure it out. But it would never look like today. So let's come back to right now. You, standing still, on an ordinary day. That quiet spin never really stopped, remember. It builds your day and your night. It shapes the very ground beneath you. It powers the shield above your head. One steady, invisible motion, doing everything. And right now, you're moving faster than a jet.